Next we will study modulus and conjugate of a complex number. Here let us take z is equal to a plus ib be a complex number. Then modulus of z is denoted by modulus of z and it is defined to be a non-negative real number square root of a square plus b square. Okay, that is if z is equal to a plus ib, a complex number, then modulus of z is equal to square root of a square plus b square. Then and conjugate of a complex number, it is denoted by z bar and it is defined to be a complex number a minus ib. Okay, if z is equal to a plus ib, then its conjugate is a minus ib, changing the sign of imaginary part. If z is equal to a minus ib, then conjugate of z is nothing but a plus ib. Okay. Next, let us see what is the multiplicative inverse of a complex number. See, z is a complex number. Then multiplicative inverse is denoted by z inverse. Okay. Multiplicative inverse of z is nothing but z inverse. If a is a number, okay, real number, then what is its multiplicative inverse? Multiplicative inverse is nothing but a inverse, that is 1 by a, isn't it? In the same way, complex number, multiplicative inverse of a complex number is z inverse, that is equal to 1 by z, that is equal to 1 by a plus ib. See here, in denominator, it's a complex number, so we have to make it in the form of a real part. Okay. So for that, we will multiply and divide by conjugate of this number. Okay, conjugate of a complex number. So here a minus ib divided by a minus ib. Okay, 1 by a plus ib. To make this real part, multiply and divide by conjugate of this number. Okay, that is a minus ib divided by a minus ib. Now simplify this one. 1 into a minus ib itself divided by, now it is of the form a plus b into a minus b into a minus b. What is a plus b into a minus b? A square minus b square, right? So here first term a square, second term ib, so I square b square, so minus I square b square. Okay, a plus b into a minus b is a square minus b square. So a plus ib into a minus ib is a square minus I square b square. Then a minus ib divided by here a square minus, what is the value of I square? I square is nothing but minus 1. So minus 1 into minus, it will become plus. Okay. So a square plus b square. Okay. So it is, see, numerator, it is nothing but conjugate of z, right? Conjugate of z, that is z conjugate, divided by denominator, that is nothing but square of modulus. What is modulus of z? Square root of a square plus b square. So what is a square plus b square? Square of square root of a square plus b square, that is modulus z square. Okay, square of modulus z, isn't it? Modulus z is equal to root of a square plus b square. Then what is its square? Its square is nothing but a square plus b square, right? So remember, multiplicative inverse of a complex number is nothing but conjugate of a complex number divided by square of modulus. Okay, square of modulus of z. Very important. Remember this one. Z inverse, that is equal to conjugate of z divided by square of modulus of z. Okay, now let us go through some questions. First question is, express each of given complex numbers in the form a plus ib. We have to make given complex number in the form of a plus ib. Okay, so let us take first one. 5 plus 4i divided by 4 plus 5i. See, denominator is a complex number. First of all, we have to make it a real number by multiplying and divide by its conjugate. Okay, that is into, here what is denominator? 4 plus 5i, right? So its conjugate is nothing but 4 minus 5i, okay, divided by 4 minus 5i. So that we will get a real number in denominator, okay. That is 5 plus 4i into 4 minus 5i, simplify, 5 into 4, 20, 5 into minus 5i minus 25i plus 4i into 4 plus 16i minus 20i square. Okay, 4 into 5, 20, I into I square, plus into minus, minus. Okay, divided by, see, it is of the form a plus b into a minus b, that is equal to a square minus b square. A square is 16 square minus 5 square I square. Okay, I square 5 square, that is 25 I square. Okay, I square 25. That is equal to, here 20, let us take it together. I is common. Okay, let us take it out. Let us take I outside. So plus I into, it is the plus term, so we will write it first. Okay, so 16 minus 25. Here 20 into I square, value of I square is equal to minus 1, minus 1 into minus plus, so plus 20 divided by, here also 16, sorry, 4 square, okay, 4 square 16, 16 I square value is minus 1, minus 1 into minus, so it will become plus, so 16 plus 25, that is equal to, here let us take real part together, real number 20 plus 20, 40 plus I into 16 minus 25 minus 9. So it will become minus 9i. Okay, divided by 16 plus 25, 41. Okay, that is equal to 40 divided by 41, separate it, minus 9i into 9 divided by 41. See, now it is of the form a plus ib. Real part is 40 by 41 and imaginary part is minus 9 by 41. Next, the second one. Second one, 1 by 3 plus 3i whole cube. Okay, so what is a plus b whole cube? We have to apply this formula, a plus b whole cube, that is a cube, so 1 by 3 cube plus a plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. Okay, apply this formula here. 1 by 3 cube, a cube, 1 by 3 cube plus 3a square, that is 1 by 3 square into 3i square, sorry, into 3i, okay, a square b plus 3 into 1 by 3 into 3i square plus 3i whole cube. Okay, that is equal to, here 1 by 27 plus, here 3 square, numerator also 3 square, 3 into 3, 3 square, it will be cancelled. Then remaining I, okay, plus, here 3 cancelled, So 3 square 9, 9i square, 9i square plus 3 cube 27, 27i cube, 27i cube. Okay, that is equal to 1 by 27 plus I square value is minus 1, so it will become minus 9 plus, what is I cube? I square is minus 1, so I cube is nothing but I square into I, that is minus 1 into I minus I. Okay, I cube is equal to I square into I, that is minus 1 into I is equal to minus I. So it is minus 27i. Okay, so here let us take real part together and imaginary part. Okay, so here what is the real part? One real number 1 by 27 minus 9. Okay, plus I minus 27i, that is, simplify this one, taking LCM, 27 into 9, here 1 minus 243 divided by 27 minus 26i. Okay, that is, here 1 minus, that is minus 242 divided by 27 minus 26i. So here it is the given complex number. Okay, see, it is of the form a plus ib. What is the real part? Minus 242 by 27 and imaginary part is minus 26. Let us go through next question. Find the multiplicative inverse of given complex numbers. First one, 3 plus 2i. Okay, given complex number is 3 plus 2i. Here we have to find its multiplicative inverse. That is 3 plus 2i inverse. We know that if z is a complex number, its multiplicative inverse is nothing but z conjugate divided by modulus z square, right? That is, z inverse is equal to z conjugate divided by modulus of z square. Okay, so here 3 plus 2i inverse is conjugate of 3 plus 2i, that is, okay, I will write it directly, 3 plus 2i divided by modulus of 3 plus 2i square. Okay, that is, here conjugate of 3 plus 2i is nothing but 3 minus 2i divided by, what is modulus of z? If z is equal to a plus ib, modulus of z is equal to root of a square plus b square. So modulus of z square is equal to a square plus b square. It's a square, that is nothing but a square plus b square. Square root will cancel. So here 3 square, okay, 3 square plus 4i square. Okay, 2 square. So 3 square is nothing but 9. Okay, 3 square 9 plus 2 square 4 I square. Okay, then 3 minus 2i divided by 9. Here I square value is minus 1, so plus become minus, so minus 4. That is equal to 3 minus 2i divided by 5. So we can write it as 3 by 5 minus 2i 2 by 5. Now it is of the form a plus ib. Real part is 3 by 5 and imaginary part is minus 2 by 5. So it is the inverse of, okay, multiplicative inverse of given complex number 3 plus 2i. Now let us go through second one. Second one, cos theta plus I sin theta. Okay, given complex number is cos theta plus I sin theta. We have to find its multiplicative inverse. So multiplicative inverse of a complex number is nothing but conjugate of a complex number divided by square of its modulus. Okay, that is cos theta plus I sin theta is equal to cos theta, its conjugate is minus I sin theta. Just changing the sign of imaginary part. Okay, so cos theta minus I sin theta divided by its square, that is modulus square. Okay, modulus of z is modulus of cos theta plus I sin theta, square root of cos square theta plus sin square theta. So its square of modulus of this complex number is cos square theta plus sin square theta. Okay, if z is equal to a plus ib, then modulus of z is square root of a square plus b square. Here square root of cos square theta plus sin square theta. Modulus of z square is a square plus b square. That is modulus of z square here cos square theta plus sin square theta. That is cos theta minus I sin theta in numerator, and denominator is cos square theta plus sin square theta. In trigonometry, first identity we have studied cos square theta plus sin square theta is nothing but 1. Okay, so denominator become 1. So cos theta minus I sin theta. Okay, so multiplicative inverse of given complex number cos theta plus I sin theta is nothing but cos theta minus I sin theta. Okay, next third one. Two plus root 3i whole square. 2 plus root 3i whole square. See here, we cannot find the multiplicative inverse of this complex number directly. Okay, so first of all we have to expand this complex number. Okay, that is expand this one, a plus b whole square. It is of the form a plus b whole square. A plus b whole square is a square plus b square plus 2ab, right? So 2 square plus 2 into 2ab, 2 into 2, 4 into root 3i. Okay, plus b square, that is root 3 square, root 3i square. Okay, that is equal to 4 plus 4 root 3i plus root 3 square is 3, I square is I square. I square is minus 1. So this plus will become minus 3. Okay. Then 4 minus 3 is 1 plus 4 root 3i. Now it is of the form a plus ib. Right? A plus ib. Okay, we can write I here also. We can write I first or last. Okay, I 4 root 3. It is of the form a plus ib. Now we can find the multiplicative inverse. Okay. So multiplicative inverse of this one, that is 2 plus root 3i whole square. Its inverse is nothing but 1 plus 4 root 3i inverse. Okay, that is equal to z conjugate. Okay, its conjugate, that is 1 minus 4 root 3i divided by square of its modulus, that is 1 square plus 4 root 3 square. Okay, that is equal to 1 minus 4 root 3i divided by 1 plus 4 square is 16. 3 square root 3 square is 3. So 16 into 3, 48. That is equal to 1 minus 4 root 3i divided by 49. So here we can write it as 1 by 49 minus 4 root 3i divided by 49. It is of the form a plus ib. Here real part is 1 by 49 and imaginary part is minus 4 root 3 by 49. Next question, simplify I raised to 4n plus 1 minus I raised to 4n minus 1 divided by 2. Given complex number I raised to 4n plus 1 minus I raised to 4n minus 1 divided by 2. Okay, that is equal to, how can we write? We know that a raised to x plus y is equal to a raised to x into a raised to y, isn't it? So here I raised to 4n plus 1 is I raised to 4n into I minus I raised to 4n into I raised to minus 1 whole divided by 2. That is equal to, what is the value of I raised to 4n? The power of I, if the power of I is multiple of 4, its value is 1, right? Plus 1, okay? So 1 into I minus 1 into minus I divided by 2. 1 into I raised to minus 1. Okay. Divided by 2. So what is I raised to minus 1? 1 by I into I divided by I. So I divided by I square, that is I divided by minus 1, that is minus I. Okay. So 1 into I minus 1 into minus I. So minus will become plus I, okay, divided by 2. That is equal to 2i, okay, 1 into I itself, I plus I is 2i divided by 2, that is equal to I. Okay, so I raised to 4n plus 1 minus I raised to 4n minus 1 divided by 2 is I. Next one, evaluate I raised to 18 plus 1 by I whole raised to 25 whole cube. Okay. Given complex number is I raised to 18 plus 1 by I whole raised to 25 whole raised to 3. That is equal to, see, we can write the first term I raised to 18 as I square raised to 9. Isn't it? 2 9s are 18. Okay. Plus, we can write it as 1 by I whole raised to 25 is 1 raised to 25 divided by I raised to 25. 1 raised to 25 is 1 itself divided by I raised to 25 whole cube. Okay. Then, next is I square is, the value of I square is minus 1. So, substitute minus 1 raised to 9 plus, here we can write I raised to 25 as I raised to 24 into I whole cube, right? Next step, minus 1 raised to 9, since it is an odd number, minus 1 raised to odd number is minus 1 itself, okay? So, its value is minus 1 plus 1 by, what is the value of I raised to 24? 24 is multiple of 4. So, the power of, if the power of I is multiple of 4, its value is 1 itself. Okay. I raised to multiple of 4 is 1. We have studied I raised to 4n is equal to 1. Okay. If the power is multiple of 4, the value is 1. Okay. I raised to multiple of 4 is 1. So, 1 into I whole cube. Okay. Next step, minus 1 plus, here what is 1 by I? 1 into I is I. 1 by I is equal to minus I. How? 1 by I is equal to 1 by I into I by I. We have to make the denominator a real number. Okay. By multiply and divided by I. That is I divided by I square is minus 1. That is minus I. Okay. I divided by minus 1 is I. So remember, 1 by I is nothing but minus I. So, minus I whole cube. Okay. So, we have got minus 1 minus I whole cube. Here we can take minus 1 outside. That is minus 1 into, minus is common, right? So, we can take minus outside. Minus 1 into 1 plus I whole cube. Okay. Now, minus 1 cube is minus 1 itself. So, minus 1 into 1 plus I whole cube. Then, see, whenever simplifying given complex number, we have to, at last we have to make it in the form of a plus ib. Okay. So, here minus of 1 plus I whole cube. That is minus of 1 plus I cube whole cube. Apply the formula a plus b whole cube. Okay. That is a plus b whole cube is a plus b whole cube is nothing but a cube plus 3a square b plus 3ab square plus b cube. Okay. So here 1 cube plus 3a square, that is 1 square, 3 into 1 square, that is 1, into b square, sorry b, okay, plus 3 into a, that is 1, into b square, that is I square, plus last term is b cube, that is I cube. Okay. Then that is equal to 1 cube is minus is there. Okay, be careful. Minus of 1 plus 3 into I, 3I. Here 3 into I square value is minus 1. So minus into plus, it will become minus 3. Okay, plus I cube, I square is minus 1, I cube is minus 1 into I, that is minus I. Okay, minus I. So here minus of 1 minus 3 is minus 2. 3I minus I is plus 2I. Okay, that is equal to, now multiply this minus here. So you will get minus into minus plus 2 minus 2I. That's all. See, now it is of the form a complex number a plus ib. That is, here real part of z is 2 and the imaginary part of this complex number is minus 2. Next question. If x minus iy is equal to square root of a minus ib divided by c minus id, prove that x square plus y square whole square is equal to a square plus b square divided by c square plus d square. See here, it's x minus y. Okay. Here LHS x square plus y square. We know that x square plus y square is the square of modulus of x minus iy. Right? So before that, let us remove this square root by squaring on both sides. X minus iy whole square, that is equal to a minus ib divided by c minus id. We have removed this square root, okay, by squaring on both sides. Okay. Then let us take modulus. Okay, why? Because see here, x square plus y square is the square of modulus of x minus y. Okay. Now let us take modulus on both sides. So modulus of x minus y whole square, that is equal to modulus of a minus ib divided by c minus id. Okay. See here, we have studied modulus of a plus ib is square root of a square plus b square. That is nothing but distance. Okay. So here, same modulus of a minus b is also a square root of a square plus b square. Okay. Modulus of a plus ib is square root of a square plus b square. Here also modulus a minus ib is also square root of a square plus b square. So here, what is this one? Modulus of x minus iy into modulus of x minus iy, that is equal to, okay, here in numerator a square plus b square, square root of a square plus b square. Okay, modulus of a minus ib is equal to square root of a square plus b square divided by square root of c square plus d square. Okay, so what is here? Here also x square, square root of x square plus y square. Okay, modulus of x plus iy is square root of x square plus y square. Modulus of x minus iy is also square root of x square plus y square. So square root of x square plus y square is equal to square root of a square plus b square divided by square root of c square plus d square. Now it is square root of root a into root a is nothing but a itself. Okay. Therefore, it is x square plus y square, that is equal to root of a square plus b square divided by root of c square plus d square. Now we have got x square plus y square. And what is its square? Square on both sides. So what we will get? See, x square plus y square whole square, that is equal to, okay, take square on both sides. So when taking square on right side, we will see this square root will be removed. So we will get a square plus b square divided by c square plus d square. Hence it is proved.